I don't know. My battery is really low, so we'll do the best we can. Um, it doesn't really charge that well. We're streaming, and let me share here. Okay. And then let's do this. So I'm pretty much pulling grades directly from Pearson. Um, Alex is only 10%, 10% of your grade. I hadn't decided. I mean, like my colleague sends me a report on what's going on in Alex, a weekly report. But 90% of our grade comes from Pearson. So pretty much the grade that you see in Pearson is the grade. I might just do a completion grade for Alex, like just as long as I see it in there, see that you've been working. You know, Alex is only 10% of our grade. It's not major. The grade that you see for attendance, you can ignore that. Like that has nothing to do with anything. Um, Again, for Alex, the goal is to get to the level of prep for college algebra by the end of the semester. Okay? But yeah, pretty much, essentially, the grade that you see in Pearson is essentially the grade. It might be hit by a little bit, by maybe like a few points, because Pearson is going to count as 90% of our grade, and then 10% is going to come from Alex, right? So the grade that you see in Pearson pretty much is the grade. I think so, Alex. I think it's supposed to tell you like what level you're at any given moment. I don't know when you'll reach it, but it should tell you. And like again, the rhythm is supposed to be doing about 25 topics a week in order to do that. Don't stress too much about Alex. Just do the best you can with Alex. The main thing is as long as Pearson is in order, that's majority. That's the bulk of it. There, do the best you can with Alex. If you have more questions or you want more details on Alex, I will point you towards my colleague Dr. Lamar. She has all of those details. Um, but I don't want you stressing about Alex. Like, do the best you can with Alex. Um, but make sure that Pearson is in order. Make sure that Pearson is in order. Okay. So let's see. Let's go like this. View, single page. Okay. So let's see. We're going to continue chapter 2. So we don't have that many sections remaining. We have 2, 3. I think we have 3, 1, and 6, 4, and then that's it for the semester. We're going to be done before Thanksgiving. Like we're going to take the final exam before Thanksgiving. So we're approaching the top of November, right? So we don't have that many sections remaining. We'll be done pretty quickly. Okay. So what that means is do your best to. Now is a good time to go ahead and get Pearson where you want it to be. Everything is there, and you have an opportunity. You just have to take advantage of the opportunity and keep it moving. So with section 2.3, we want to move into take a look at dividing polynomials and the rational zero test. We want to learn the division algorithm. We want to use the remainder and factor theorems, and we want to use the rational zero test. These are some objectives for this section. So then we say a polynomial is a factor, a polynomial d of x is a factor of a polynomial f if there is a polynomial q such that f is equal to d times q, right? With no remainder. The quotient is going to be, what is this? The divisor divided by the dividend, and this is the quotient. That's what this is. This is basically similar to like when we do long division with numbers. The terminology is what it is. Just kind of do your best to kind of get through this slide. But then in practice, again, it's going to be similar to like if we were to do something like, let me see, 5, 7, 6 divided by 3, right? You know how you would do long division here? We're going to do something similar with polynomials. It's going to be very similar to this. Some of the main steps are going to be the same. So again, if a polynomial f is divided by another polynomial d where there's no remainder, there are unique polynomials q and r such that, let me see, the divisor divided by the dividend equals the quotient plus the remainder over the dividend. I think that's how that goes, right? Nope, I mixed up some of my terminology. The dividend is going to be the divisor times the quotient plus the remainder. So, don't stress too much about this. In practice, you'll see how all of this unfolds, right? It'll, to me, it's a lot easier to view something like this in practice. So let's give this one a go. I think we need some space. Use long division and synthetic division to find the quotient and remainder. Okay. So let's start off with polynomial long division. Okay. Let's go like this. Paper, like this. So then we're doing polynomial long division. So let's see. 4, 3, 2. Okay. So we're going to say x plus 2 divided into 2x to the 4 plus x cubed minus 16x squared plus 0x plus 18. Okay. So notice I did a placeholder. We have to make sure that every exponent is accounted for. We start with a degree 4. We have a degree 3, 2. The degree 1 was skipped over, so that's why I did the blue placeholder, and then the degree 0. All right, so all the exponents have to be accounted for when we do these next two maneuvers, right? So then for polynomial long division, what we do, we say the first divided by the first. So if we say 2x to the 4 divided by x, that's going to give us 2x cubed. Right here, 2x cubed. So next, in this direction, we want to multiply. Right, we multiply. So then 2x cubed times x is going to be 2x to the 4. 2x cubed times 2 is going to be 4x cubed, right? So now in regular long division, at this stage, we would normally subtract. So we're going to do the same thing here. We need to distribute a negative. Okay. If we distribute the negative, the first term adds to 0. 1 minus 4 ends up being negative 3x cubed. And then the negative 16x squared just comes down. Okay. So now we repeat the process. We say the first divided by the first. So then negative 3x cubed divided by x is negative 3x squared. Okay. And then in this direction, we multiply. So negative 3x squared times x is negative 3x cubed. And that's going to be a negative 6x squared. And we distribute a negative. So this becomes positive, this becomes positive. The first term adds to 0. The second one we get negative 10x squared. Let's see who do we have. All right. And then I think the 0x comes down. Okay. So then negative 10x squared divided by x is going to be negative 10x. All right. And then here, in this direction, we multiply. So that's going to be negative 10x squared minus 20x. Again, we distribute a negative. So this becomes positive, this becomes positive. This is 20x, and this is 18. Okay. Sorry. So then, now we repeat the process again. So we're going to say 20x divided by x gives us 20. Whoops. Why does it look like that? It gives us 20. And again, in this direction, we multiply. So we get 20x plus, whoop, let me get rid of that plus. Oh, switch this to the whole, and it doesn't need to be that big. Okay. So 20x plus 20, and then we still need to distribute a negative. So this is negative, this is negative. As to 0, did we do this right? I feel like we missed something somewhere.
Would you not do 20 times 2?
20 times 2 is 40. There it is. I was like, something didn't look right. Okay. So 20 times 2 is 40, right? Okay, that it's better. So then 22, so it's going to be a negative 22 is the remainder. So then the solution, when the first polynomial is divided by that monomial, copy. We're going to say this plus the x plus 2 under the negative 22, right? So that was a demo. That's a demo on polynomial long division. Oops. Okay, now let's do a demo on synthetic division. All right. So in synthetic division, I need a copy. Let me get a copy of this. All right, so we want to say this polynomial divided by x plus 2. So again, if we're saying that divided by x plus 2, when we go to do synthetic division, we want the potential 0. So the 0x comes from every exponent has to be accounted for. We started with the degree 4. That means we need a degree 3. We also need a degree 2. We need a degree 1, and we need a degree 0. Right? So we need to use placeholders to make sure every exponent is accounted for. So when we go to do synthetic division, if we're dividing by x plus 2, that means a negative 2 needs to go in the chair. Right? Negative 2 needs to go in the chair. So then we take the coefficients, right, from the original. So we're going to have the 2, 1, negative 16, again, the 0 placeholder, and 18. Okay? So now with synthetic division, the way it goes, the first one just comes down. So that's a 2. And then on a diagonal, we multiply, right? So basically like negative 2 times 2 is going to be negative 4. On the vertical, we add. 1 plus negative 4 is negative 3. Negative 2 times negative 3 is what? Positive 6. So basically, you bring down the first one, then it goes multiply, add, multiply, add, multiply, add, multiply, add until you get to the end. Right? Negative 16 plus 6 is negative 10. Negative 10 times negative 2 is a positive 20. Adds to 20. That's a negative 40. Negative 22 is our remainder. That last number is going to be our remainder. So if we started with the degree 4 polynomial, at this stage, we're not, this is called the depressed equation. At this stage, we now have a degree 3. So this is 2x cubed minus 3x squared minus 10x plus 20. Okay, and I think we get the same result, right? It should be the same. So when we did polynomial long division or synthetic division, we got the same thing. 2x cubed minus 3x squared minus 10x plus 20. And that negative 22 is the remainder. So it goes negative 22 over x minus 2. Right? And I think we have a type version of what we just did. Okay. So then next notion that we want to explore is this notion of what we mean by the remainder theorem. Yeah. How does that name not sound familiar? Oh, because it's not one of our students. I was like, who is that? That's why I have a waiting room. I'm like, I don't know who that is. And so when they saw they were in a waiting room, they just like left. That's too funny. Okay, anyway. All right. So if a polynomial function is divided by x minus a, then the remainder is given by f of a, right? So let's see this in action. So it says find the remainder when this polynomial is divided by x minus 1, right? So the remainder theorem, we can essentially do f, replace the x with the 1, right? So f of x equals 2x to the 5th minus 4x to the 3rd plus 5x squared minus 7x plus 2. And what's the x in this case? X in this case is 1. So if we evaluate when x is 1, that's going to give us our remainder. So this is going to be the same as 2 minus 4 plus 5 minus 7 plus 2. Right? 2 plus, notice that these three cancel each other out. 5 minus 7 is negative 2. So our claim is that when f of x is divided by x minus 1, the remainder is negative 2. Let's see who this is. Okay. It's a name that we can work with. It's going to be all the way here, right there. That's fine. It's not a big deal. All right. And so we can verify this. We can verify this by doing synthetic division. Right? So if we're dividing by x minus 1, the potential 0 is going to be positive 1. So 1 goes in the chair. And then we take all the coefficients. First, we check the exponents. Notice they go 5. We're missing the 4. 3, 2, 1, 0. So we need a placeholder for the power of 4, right? So we're going to have 2. Again, we have our placeholder 0, negative 4, 5, negative 7, and 2. Okay? So then if we do synthetic division on this, again, the first term just comes down. What's this? On the diagonal, we multiply, so we get this. We add, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, we add, and this is our remainder. And notice we got the same. So whether we did, we evaluated when x is 1, or we do synthetic division when x is 1, in either case, the remainder was f of 1 in this case.
Why did you cross out those numbers?
The 2, the negative 4, and the 2?
Yes.
Because I just added them. 2 plus 2 is 4.
Oh, that's how you got negative 2. Oh,
yeah,
okay.
Yeah. 4 minus 4 is 0. So then 5 minus 7 is negative 2. Okay? Yeah, no worries. All right. Let's see what else. So here's a type version of what we just did. Find the remainder when this polynomial is divided by that binomial. So then we did f of 1. We got negative 2. The remainder is negative 2. Okay. So let f of x be this. Now we're asked to evaluate when x is negative 3. Now, I mean, we could just plug in x equals negative 3, but not notice, like that first term is x to the 4. So what is that going to be? 81, 27? I mean, we get some pretty big numbers, right? So the remainder theorem can actually be used in reverse. What we just saw was if we wanted the remainder, we evaluated the function. Now, if we want to evaluate the function, just find the remainder, right? We can use the remainder theorem in both directions. So let's do synthetic division here. So in this case, the -3 goes into the chair, and we take the coefficients. We got to make sure that every exponent is accounted for. Notice it goes 4, 3, 2, 1, and then a degree of 0. So every exponent is accounted for, so we're okay there. We don't need any placeholders. So then we just take the coefficients. So we have this 1, 3, -5, 8, and 75, right? Okay. And then we do synthetic division. Synthetic division, the first term or number just comes down. On the diagonal, we multiply, we add, we multiply, we add, we multiply, we add. What is that? 69, -69. We multiply, we add. This last one, we're going to add 6. I think it's just going to be 6 even, right? So our claim is that when we plug in -3 into the original, the answer is 6, all right? Now, we can confirm this with our calculator. Let me pull up my trusty dusty rusty right here. We're going to shrink you down. Come on. It's better. All right. So now, what I'm going to do in my y equals, I'm going to do x, I'm just going to type in the original, plus 3x to the power of 3 minus 5x squared plus 8x plus 75, okay? So now I'm going to quit, and I'm going to call on that function the same way I've done several times in the past. So when x is -3, the answer should be 6. Awesome sauce. Okay. X was -3, y was 6. Okay. I guess. I don't know. That looks nice. All right. Let me see what else do we need. What's the time? Okay. So let me pause for the cause. Are there any questions? If there aren't, then I'm just going to kind of keep moving. Okay. So here's a type version of what we just did. We got this f of x when x was -3. We see if we just evaluate it, we get an answer of 6. And if we do synthetic division, we got an answer of 6 as well. Okay, I think we did both of those.
Oh, I have a question.
Go ahead.
So after you call on to the y, so you put everything into y equals, what do you do next?
What do you mean, put everything into y equals? What do you mean?
I mean, on your calculator.
Oh, on the calculator. Okay. So, and this is a TI-83 Plus. Now, this is only in the TI-83 Plus. I don't know about other calculators. So once I finish with the y equals, to the left of the clear button is a button that says VARS, variables. I click there. So if I click on variables, then I go to the right to go to y variables. I click on number 1 for function, and number 1 again to call on the function that I just typed in. And then once I have that there, if you hit second enter, it just keeps calling on whatever the previous thing that you typed in. So I just kind of keep recalling it and editing it. So this is like basically doing like f of -3. Okay. All right, let me see. Okay. So now we have the factor theorem. With this one, it says that a polynomial has x minus a as a factor if and only if the remainder is 0, right? So if we say a polynomial divided by this, if the remainder is 0, then it's a factor, right? Or we could just do f of a equals, and if it equals 0, then we say it's a factor, right? Again, this comes out of the remainder theorem. Okay. So given that 2 is a 0, solve the polynomial equation. Let me give myself some spaces. I think I ran out of space with my last week. And let's change this view to seamless. Okay. So now we're given that 2 is a 0. So let's confirm indeed that 2 is a 0. So if 2 is a 0, when we do synthetic division with the zero, the proposed 0 in the chair, let's take the coefficients. We got 3, we have 2, we have negative 19, and we have 6. Every exponent is accounted for. We have 3, 2, 1, 0, so we're clear there. Okay, so let's do synthetic division. So the first number just comes down. 3 times 2 is 6. 6 plus 2 is 8. 8 times 2 is 16. That's going to be a negative 3. That's negative 6. And indeed, we get our 0. Right? So we started with a degree 3 polynomial. Now at this stage, this is called the depressed equation. At this stage, we now have a degree 2 polynomial. Okay? Okay? So let me see. Now, we confirmed that since we got a remainder of 0, that means 2 is indeed a 0. So now, at this stage, we have that what? X minus 2 times 3x squared plus 8x minus 3. Again, we're solving the equation of this equal to 0. We're just factoring the original. So then, let's see, can we go ahead and factor that 3x squared plus 8x minus 3? Now, there are several ways of factoring this quadratic. We can use quadratic formula. We can use completing the square. I'm going to use this method called the box method for factoring trinomials, right? So we're looking for two numbers that multiply to give us negative 9 and add to give us 8, right? So the first one is negative 1 and 9, and those just happen to be the two numbers that we're looking for. Okay. So what I'm going to do, I'm going to rewrite this 8 using those two numbers that we found, and I'm going to use the box method. Let's do like this for the box method. So if we're doing the box method, we have something like this. In the upper left-hand corner goes the leading term, which is this 3x squared. The bottom right-hand corner goes our constant, which is negative 3. On the other diagonal, we rewrite that green 8 using the two numbers we found. So instead of writing 8x, we're going to write negative x and a positive 9x, right? So now, if we look at the two numbers on top, what do the two numbers on top have in common? They both have x. What do the two numbers on bottom have in common? Well, we can factor out a 3. What do the two numbers on the left have in common? We can factor out a 3x. What do the two numbers on the right have in common? We can factor out negative 1. This is called the box method. I actually pulled this from YouTube. Actually, some of my students in the past showed this to me first, and then I kind of researched it a little bit, and I confirmed what they were doing. I was like, oh, okay, I like it. So this is just one way. There are a lot of others, but if you go on YouTube and type in factoring the trinomial, there are others that pop up, right? So now our claim is that the x minus 2 just comes down. I'm watching the clock. And then that the black and green at the top factors into 3x minus 1 times x plus 3 equal to 0. Okay? And so we could confirm, right? 3x times x is 3x squared, right? So we're good there. 3x times 3 is 9, minus 1 is indeed 8. right? So that works. And then -1 times 3 is -3. Okay. So now we can use a zero factor property. We have two or more things that multiply to give us 0. So we set each thing to 0 and solve. We get x equals 2. We get a third. And we get -3. All right. And we should check this. We should check and confirm that these are indeed the zeros of the original polynomial. Okay. So we're going to do the following. Just trying to see the original. Right here is good. Okay. So what I'm going to do, I'm going to go to my y equals and type the original in. We got this 3x cubed, so 3x to the power of 3, plus 2x squared, minus 19x plus 6, right? Then when y is 2, so when we plug in 2, we should get 0. When we plug in a third, we should get 0. And when we plug in -3, we should get 0. Okay? So we confirm that those are indeed our zeros, and we're golden. All right, let me see. So those worked out. And I think that's the same place that my earlier group stopped. I'm going to go like this. And say stop here. What's this, Monday, October, what's the date, the 26th? Oh, yeah, we are far in the future. Come on. Okay, you're not going to do what you need to do. 2020. So then, tomorrow, start here, Tuesday, the 27th. Okay. If there aren't any burning questions, we're pretty much where we need to be. I'll let you guys go. I'm gonna go ahead and load a copy of this and make it available for you all to call upon. Let me go ahead and do that quickly here. This one. Come on. This one. Come on. Yeah, if there aren't any burning questions, guys, I'll see you tomorrow, inshallah. Okay, see you guys.
Thank you.
Did we skip over 2.2? Okay.